Hi and welcome. I'm trying to learn particle physics. Today the matter-antimatter imbalance, and after we've done that we're going to do a bit standing yoga, and if you participate in the standing yoga then it's better at your own risk. But first we want to read shortly about the timeline of antimatter, but first we want to read the end of a chapter of antimatter. It was written, I don't know if it was written important, but I'm just going to read it short. So what is antimatter good for? That is one of the favorite questions of Tara Shears at CERN's Large Hadron Collider beauty experiment. Antimatter is really esoteric, isn't it? She says. You probably don't expect antimatter to help diagnose cancer or help with heart problems or have any practical benefit at all, but it does. Positrons make up the P in a PET scan, which stands for positron emission tomography. Here, the inhalation emissions of positrons in the radioactive tracer you swallow can illuminate all sorts of potential internal nasties. Okay, people can take, I think we're saying, some type of tablets, and they are then causing the body to emit positrons, and these positrons can be checked with a radio measurement, whatever, and that can help to find ailments in the human body. Okay, timeline of antimatter. In the year 1898, physicist Arthur Schuster coins the term antimatter in two whimsical letters to nature speculating about negative matter. Okay, after Schuster has coined the term, and he was writing a letter to someone and needed a word to the thing he was thinking about. 1928, Paul Dirac's equation describing the electron indicates the existence of a positively charged antimatter electron, the positron. Paul Dirac's equation describing the electron indicates. So he was writing an equation about the electron, and that equation about the electron indicated that there is also a positively charged electron, an antimatter electron, and that would be called the positron. Okay, 1928, Paul Dirac wrote an equation about electrons, and that's how it was written down, indicated it has to be something with the opposite charge, the positron. 1932, Carl Anderson discovers the positron in cosmic rays. And 4 years later, that was Carl Anderson. He was looking into the sky and he saw the positron. 1964, discovery of CP violation, an asymmetry in processes producing matter and antimatter, in processes involving strange quarks. Okay, 1964, the CP violation was found, and that is about it. There is more matter than antimatter. They said here in one part, not every particle has an antimatter equivalent either. Bosons, the particles that transmit influences within the Standard Model, tend to be their own antiparticles. 1982, the low-energy antiproton ring, LIR, comes into operation at CERN with the aim of manufacturing antihydrogen. Okay, at CERN in Switzerland and France. I think they're saying always Switzerland, but it goes under France. And I think that the station on top of it, because with how things are under the Earth, the station is in Switzerland, but that whole thing with the whole big circle reaches under France. Whatever. Okay, where in Switzerland? There is a building and there are people doing science, and people are trying to make not just hydrogen, but anti-hydrogen. And some ring is necessary. I don't understand. 1995. Lear makes the first atoms of anti-hydrogen. Is Lear a person? Is Lear a product? Lear makes the first atoms of anti-hydrogen. But they are traveling too fast to study. Okay, someone or something called Lear has made anti-hydrogen atoms, but they cannot be studied because they're just too fast. 2000. CERN's antimatter factory starts up. using learned successor, the antiproton decelerator. I get it. The low-energy antiproton ring, called LEAR, comes into operation. In CERN, they have different types of rings. Maybe we have one very small in the entrance floor when you come in, which has one small so that people can see it in the model. And maybe we have another one somewhere else. We have a 2 meter big one so that you can check what's going on. And then we have somewhere else which I think is 5 kilometers big or whatever. And we have different ones of them. That makes sense. But we're not using the same from the 80s. And in the 80s, 1982, they had a ring and they gave us the name LEAR. In 1982, they worked on that one with the name LEAR. That's what I'm saying. The low energy antiproton ring LEAR. In that ring, which was used low energy as antiproton, they tried to make hydrogen. And this ring called LEAR, when actually made in 1995 the first anti-hydrogen, just too fast to study. And in 2000, CERN's antimatter factory starts up using LEAR's successor, the antiproton decelerator. They had an antiproton, low energy antiproton ring, yet now they have an antiproton decelerator. Whatever. This we were too fast to study. That means it's more complex what we're doing there. Now, since they're not just trying to do things there, they're also trying to do the things in slow motion. So that they're not too fast to study. Okay, and after LEAR was retired, or they're using both now, they're using now something else, the antiproton decelerator, and with that they're doing lots of things. 2001, discovery of CP violation in processes involving bottom quarks. Okay, there's some types of particles, they're called quarks, and they're up, and positive and negative quarks, and some of them are bottom quarks, and they are not symmetrical with the antimatter quarks or whatever. 2008. The Large Hadron Collider starts up with a dedicated LHCb experiment. That was a Large Hadron Collider beauty project. What does it mean? What does it mean? With a dedicated LHCb experiment looking at the rare antimatter processes. Okay, since 2008 they started with a Large Hadron Collider in Switzerland to look for antimatter processes in the big LHCb experiment. 2014. The Escasos experiment observes anti-hydrogen atoms in a field-free region. Needed to make accurate measurements. Okay, they have an experiment when they want to count not the experiment and the experiment because they don't want to bump into the other scientists who also had an experiment called the experiment and then they're in the wrong room. So they called it everyone for the experiment Asakusa as the company. Okay, they're making an experiment with the name Asakusa. And they are having there not just this hydrogen, but these anti-hydrogen atoms. They're having them in a field-free region. That means they put everything away that they could. And that is needed to make accurate measurements. That makes sense. So no one should bring their phones, so no ringtone disturbs what's going on there. But maybe that doesn't interfere with it, so that's no problem. 2017. The base experiment at CERN's antimatter factory measures the antiproton's magnetic moment to an accuracy of 1.5 parts per billion. It is all in uppercase. Without the, we have quotation marks, but not quotation marks, whatever we call it. The other things. The base experiment at CERN's antimatter factory measures the antiproton's magnetic moment to an accuracy of 1.5 parts per billion. Okay. A big experiment there in Switzerland at CERN could measure. I'm not familiar with handling the term magnitude. I don't get it. I don't understand the word really. I don't understand the concept of the word magnitude. Maybe I should look better up what it even means. They want to know how big the antiproton's moment is. In short, there isn't even the word magnitude, there's the word magnetic written. So no one has said anything about magnitude, there's magnetic written. We want to know how big the magnitude of the magnetic moment of the antiproton is. Maybe that's simpler to understand. And they were able to do that to 1.5 parts of a billion. Whatever. We know pretty much how magnetic the anti-hydrogen protein is or whatever, something. Anti-hydrogen proton. Better than the equivalent proton measurement, the two are consistent. What? Better than the two equivalent proton measurement, the two are consistent. Whatever, it didn't cross out the work we did before because it all fits together. 2018, both the anti-proton decelerator and the LHC are switching off for upgrades. They're making a break in 2018. 2019, LHCb discovers a CP violation in a process involving charm quarks, the final type of process in which current theories predict it. Okay, there are other types of quarks. There are the plus and the minus and the up and bottom and strange, and there are the charm quarks. And there was discovered that there's also the CP violation, that there's more matter than antimatter. And some theories are predicting that that is there, and that was now discovered that it is so. 2022, the upgraded LHC and the new extra low energy anti-proton ring ELINA are due to come online. And with them the first antimatter gravity experiment. Let's see it again. The upgraded LHC, Large Hadron Collider, and the new extra low energy. Oh, that was brought down in 2018 to upgrade it. Okay, they upgraded for 4 years. And it doesn't have to be necessary. Maybe we were faster with the LHC. In 2022, where it is scheduled that from then on, the Large Hadron Collider in an upgraded version, and another one called ELINA, which is a low energy anti-proton ring. That thing runs with low energy and it's therefore slower and this is therefore easier to see what's going on. Whatever, something. And they should start to work. And with them the first antimatter gravity experiments. And we want to do experiments with antimatter gravity. We want to know what gravity the antimatter has. I think this is a fair question to want to know it. Now, that was the particle physics part. If you were here for particle physics, you can go directly to the next part of particle physics. We will continue with the matter-antimatter imbalance. We didn't come as far as I thought. We will do now with standing yoga. We have less time left as I thought. If you participate in the standing yoga, then it's better to let's careful feet standing together and we're breathing in and breathing out. And out and down. I think it was the sprouting flower. Breathe in and up. Out and down. Again in and up. And out onto the side, but least of the side, in and up. Out to the other side. In and up. Inch space between the feet and out to the side again. And go down. Hide and seek playing palm 3. Again in and up. Out to the other side. In and up. And out and down. In and up. And lean onto the knees. We're doing standing. Getting up. Breathing it in. And out, make a head of the back. Again in. And out, make a round back. Again in. And out, make a head of the back. Again in. Out, the belly of the back. And into the middle. And out, come with it, out, back up and make it the back. Make it the top and back of the shoulder. Refinish the answer. Out down to the side. In and up. Out the arms of the sides down into the chair. Breathe and come half here. Come high up. And out and come up. Breathe and reach high. Out up to the side. In and up. Out the arms of the sides down. Breathe and come up. And out and coming up again. And breathe and reach high. Come up onto tiptoes. And breathe out, sinking down into the chair. This exercise can go to the knees. Breathe again in, come up. And out and down. In and up. Out the arms of the sides down, we come down.
Salto Angelo, just keep stretching down, keep hanging down. Don't try to reach down, just keep hanging down. Now, open the legs to the side, and we're doing the Bianca half forwards. Go over to one leg. Breathe again in. And out, go over to the other leg. Breathe in. Out into the middle. Breathe in. And out slowly with the long leg up, back at the top, backwards, shoulder roll. Have the feet same together, breathe in, lift the arms up. Breathe out, lean back, drop shoulder bits together. For curve in the morning. Breathe in, lift the arms up. Out, leaning and back, drop shoulder bits together. In, over, cross the arms and turn the fingers at each side, screw. Out, down, change the other crossing, breathe and reach again, high. Out and down, lean back with long arms for Sky Yoga.
Out again, back. In and up. Out the arms down. And one eagle wing. Out and down. And we're ending with a cactus collecting instincts in the evening. Arms up, breathe in, hands to touch. Down to heart center. That was the first standing yoga. And thank you very much. Until the next time.